How's it going, Eliminators? Today, we're going to be working on a John Deere TRS26 snowblower that came to me and it did not start. Now, once we tear it down, I realized that someone else may have worked on this machine, so there is a little bit of detective work that's going to be required to figure out exactly what was done and what needs to be done to fix it up. But it is an in-depth video and it will take you through pretty much every step that you would need to know to do a valve job on a snowblower engine. With that being said, let's get right into it. So I currently have a John Deere TRS26 snowblower in the shop. I'm doing a leak down test. I have 50 PSI from the compressor side going into the cylinder, and you can see the cylinder side here registering at less than 5 PSI. Now, coming over to the valves, I've pulled the side valve cover off. Both of the valves are in what we believe to be the closed position, and right now we have air leaking out of the exhaust. So what happens is when the piston comes down on the intake stroke and the intake valve opens up, instead of having all of the air suction come through the carburetor to draw that fuel up into the cylinder, what's happening is it's sucking some air back through the exhaust into the cylinder and weakening the suction at the carb side. So that's going to prevent the engine from starting. Now, one of the telltale signs of an exhaust valve leak is going to be an overheated muffler here. So a lot of times you're going to see these things with the paint cooked off of them. But if your muffler is getting sometimes glowing red hot, what that means is a little bit of that combustion inside of the engine. So a little bit of that explosion is leaking out of the exhaust valve, and it's basically fire that's going to be spitting out of your muffler. Now, this engine also has what's known as an automatic compression release, which is essentially just a little counterweight on the exhaust valve side. So this is the exhaust valve here that slightly opens up the exhaust valve and then closes it on your compression stroke. And that just allows a little bit of compression to escape. But that only usually happens under 750 RPM. Once the engine runs and surpasses that 750 RPM threshold, the counterweight system does not open that exhaust valve up there on the compression stroke. Basically, it's just to help you start your machine. So at this point, you can see that both the intake valve on the left side and the exhaust valve on the right side are opening and closing. So it's not a case of the exhaust valve seized into the valve guide in the open position. And because of that automatic compression release mechanism that vents a little bit of compression out of the exhaust side, using a standard compression tester like this one here with just the regular tube to the gauge, I can put a picture up on screen just to show you what a false reading will kind of give you. Basically, it's going to show you that you might only have like a low side of 30 PSI, but that's actually because the automatic compression release mechanism is kicking in and venting out some of the pressure that would normally be going to your gauge out the exhaust. So in a situation like that, you're going to have to use one of these cylinder leak down testers. I've done a video on using this machine. They're very simple. Basically, you just take your compressor side, plug it into here, and take your tube where your spark plug goes, so that's going to be your cylinder side, and then you just load up the air from your compressor, and you guys could see that we were at about 50 PSI from the compressor that we were putting into the cylinder, but the cylinder was only holding about 5 PSI. Now, the rest of that air pressure was escaping from the exhaust, which is what you heard when I took my palm and covered up the holes on the muffler there. So that basically tells you that you have an exhaust valve leak as long as you get the piston to either top dead center or bottom dead center in a position where both valves are going to be closed. As far as I can tell, this engine just has an exhaust valve leak, and I'm just going to have to go ahead and start tearing it down to have a further inspection at the internals of this engine. And then now I can go ahead and remove the cylinder head. Obviously, I'm going to have to replace the head gasket, but we can see that the head gasket has not blown out by the looks of it. Looks to be in okay condition, and I'll just go ahead and pull that off. Cylinder looks all right. So this is our issue, I think, right here, right? That's got to be our exhaust valve, and it's pretty wet. Doesn't look like it's been burning at all. So in fact, our intake valve here looks almost like an exhaust valve. This is kind of backwards, and this is actually wet, so I can see this hasn't run for a little while, and it's just been pulling fuel and crap through it, we do know that there is in fact an exhaust valve leak. So now I just go a little bit further with my diagnosis. Now, before I go ahead and remove the valve, I want to show you guys a little trick. With the piston at top dead center, both of these valves should be in the closed position, all right? Now, one little trick to see if your valve isn't closing all the way, go ahead and take your fingers and try to rotate that valve. You see how I can't rotate the intake one? Because the spring is pulling it down so hard so that the valve face there is up against the valve seat, and it's creating such a tight seal that I can't spin that. Now watch what happens when I do that on the exhaust valve side. See that? Now this is really weird. So again, I haven't, taken anything apart yet, but I want to show you, here's the seat, right? That's that ring around here. The seat normally doesn't look all that clean because again, right, it's going to get a little carboned up. So you can expect it not to look perfectly clean. That's the intake side. Now check this out. If I spin this around and we open up, like you guys can see it already. You see that exhaust valve seat right there? I'm going to try and zoom in. That thing looks like it's got a mirror finish, and it almost looks as if someone has just cut that. I mean, look at that. That looks perfectly brand new mirror finish. So I don't know what's happened with this engine, but it appears that someone has cut the valve seat, because I've never seen an exhaust valve seat that clean unless it was just cut. I mean, that, you guys are seeing it right there. Look at that, thing's like mirror finish, and you can even see a little tiny burr on there as if somebody's gone ahead and cut that thing. Like look at how clean that is. So again, guys, if you're working on equipment that somebody else has worked on and you're not sure what they've done, you got to do this detective work. So what happens on these engines is, if somebody does, let's say, an exhaust valve replacement, the exhaust valve that you install may be longer than the old one. Now, normally what you have to do is come down here and you grind the tip of your valve. Now, before I go ahead and remove the valve to grind it to get it to size, I'm going to do just a quick tolerance check using a set of feeler gauges here. Now, different manuals for this engine, this is a Tecumseh HMSK80 that's on this John Deere TRS26 here. I've read HMSK80 service manuals before, and at the beginning of the manual, you get a spec of about 0.06 of an inch for your valves, and then later on in the manual, they contradict themselves and say 0.08 of an inch. Now, what I've heard is that your valve spec, right, the distance between the valve stem tip and the tappet should be anywhere from 6 to 12 thousandths of an inch. Now, you have to remember that on the exhaust side, things are going to heat up, right? That exhaust valve is going to expand because of the heat, right? So when things expand, the tolerances are going to get tighter. So normally what you would see is something like 6 thou and 8 thou, or 8 thou and 10 thou. Basically, on these engines, I normally set them to about 8 thou on both or 10 thou on both. You really don't have any big issues with that, but you'll notice that I have a 10 and a 12 as well. And the way to check this is rotate your flywheel until your piston here is at either top dead center, or what I've done is rotated it past top dead center on the compression stroke. So now we're starting to go down on what's known as the power stroke, where both your valves should be in the closed position, right? So the valve stem is going to be as far down as possible. Then you're going to take your feeler gauge and you're going to go in between the tappet and the valve right there. And you can see that the 8 on the intake goes in very easily. So we're going to go over to the 10 and we're going to put that one in. And you guys can see that one goes in, but I can just feel it starting to grab a little bit. And then if I rotate over to my 12 thousandths of an inch one, that one doesn't want to go in. You guys can see it. It's very difficult. So I'm assuming that the intake here is about 11 thousandths of an inch. So now coming to the exhaust side, which is the side that we had an issue with, I have, it's hard to see, but I have the 8 thou here. And I'm going to try to put the 8 thou in between the valve and the tappet, and that's way too tight. It doesn't even want to go in. So like I said, what we're going to do is just grind the tip of the valve stem, and then that will remove material from the valve. which will thus increase our tolerance in between the valve and the tappet. And that's the clearance that we're going to enlarge to get the valve to pull down farther into the seat to get it to the point where when we try to spin it, it will not spin. There you go. So now we can pull the valve out. Now, this is important. You want to make sure you're grinding it flat. Now, I don't have a valve grinding tool, so I can't machine that down perfectly flat. So basically what I did is just went on the bench grinder and touched it to the bench grinder. There you go, guys. So using our little tool there, $1.50, look at that. And the valve is now back in. So you don't need any special, valve spring compressors. You can do this with basic tools in your shop. So now is the big test. Once again, try to move that intake valve and it does not rotate. And then we'll try to move that exhaust and check that out. So we cannot move that just using my fingers. So if I come down to the valve here and I take, let's go with 8 to start with, just to show you guys, 8 thou. So we're gonna come down here and I'm gonna try to get a reading. See if I can fit that in there. See, it's still tight. It doesn't even wanna let the 8 through. However, our valve is no longer turning. So we're headed in the right direction. So I'm gonna go ahead and pop that off again. Like I said, it doesn't take long. You just go in there and bend that little retainer, boom, pull the valve out. Filing down the tip of the valve stem ever so slightly, because you guys have to remember that if you do go over and you grind away too much material, what's going to happen is the valve, it'll take a little bit longer for that tappet to lift up to make contact with the valve stem if you go ahead and remove too much material. Just to kind of point this out, these old engines are pretty much like indestructible, right? Like I've seen them take a lot of abuse. Guys run them on low oil. These things run forever and they rarely need a valve job. So, apart from like lapping the valve to increase the seal or, do what I'm doing here, which is just file the tip to make a nice little adjustment, these things don't really need serious attention internally. They've been built very sturdy and they're incredibly reliable. So, it just goes to show you that a little bit of maintenance is required on these engines every now and then, but once I finish up with this work, it should start first pull and run perfectly. So once again, the importance of getting a nice flat grind on it. Like I said, I'm just doing that on a bench grinder, and then I just went and took off the burrs. It may look like there's burrs on the edge, but that's actually where I filed the burrs down. So the main thing is that you want a nice flat edge on that, because if you have, let's say, an angle cut on your valve, if you try to put the feeler gauge in on the downward side, it might not go in, whereas if you spun the valve and you had it on the edge where it was a little high, the feeler gauge could slip right in easily and it can kind of throw your reading off. So you want to make sure that you're grinding the head of that valve stem nice and flat. And once again, put it back together, test it again. So a little bit of valve grinding compound, commonly referred to as valve lapping compound. I've gone ahead and put some on the underside of that valve there, and then I'm going to rotate the flywheel around to the point where the exhaust valve is closed, because again, you guys saw me rotate that around by hand, right? So there's a perfect spot, because if the intake valve is open, then that means the exhaust valve is all the way down as far as it can go. And then you get one of these here, right? And you stick that on there, and then we're gonna spin that around by hand, and you guys hear that grinding. So that is going to create a finish on both the valve and the valve seat that match one another. So valve lapping is an important process of doing a valve job. And just to show you guys, there's the seat now. So it doesn't have that mirror finish or that little burr that, looked like somebody had just cut a seat fresh and that it hadn't even ran. Okay, so right now I have the engine set to just past top dead center of the compression stroke. So the piston has started to move down on the power stroke, which means that both valves are closed. Now, I have my Johnny bar here with a 15/16 socket on there to hold the flywheel nut, and I'm just holding the Johnny bar to prevent the flywheel from rotating. Now, just to show you guys, I have the 10 thou feeler gauge on the intake side, and it's moving, so you guys know that the intake valve is in the most closed position. Now you're going to hear air seeping out of somewhere, and it is not the exhaust side, but listen for the change in air pressure. So it is leaking out of the intake side as well, and it just wasn't as apparent before because the exhaust side had more of a leak. So, you know, air is going to take the path of least resistance, which meant that most of the air was coming out of the muffler. And now that we've sealed up the exhaust side, you can tell that the intake side is leaking as well. So basically, I'm just going to do the same step that I did with lapping in the exhaust valve. I'm going to do that on the intake side, see if I can get this side sealed up again, because right now I'm putting 50 psi into the cylinder and we're only holding at about 25 psi, which means about 50% of the air pressure is escaping through here. So if we can get that intake side sealed up and we can get it to about only 10% loss, which is around normal past the piston rings there, then this engine will be right ready to go back together. So just using a wire brush here on my drill, went ahead and cleaned up not only the top of the piston, but the valve seats here and inside, made everything all clean. Now, once I go ahead to reassemble this and then, you know, get a new head gasket on here, I'll clean up the head gasket mating surface. But for now, everything's all nice and clean. So now I can go ahead and lap the valves in, and then everything should be sealed up. So I just wanted to point something out for you guys that are going to be doing valve jobs. The face of the valve is this angled section right here. Now, the area that's a lighter gray, that's going to be the area that I've lapped, and that's going to be known as the interference area between the valve face and the valve seat. So right there, okay? Now, the issue, and I'm going to show you guys this, is that the interference area is at the bottom of the valve face. Now, ideally, you want that lap mark, right, that lighter gray ring, to be in the middle of the valve face. So what I'm going to do is I'm going to put up a diagram on screen. This is right from Tecumseh's HMSK80 manual, and it's going to show you that interference area. Now, A is going to be the correct interference area, and right now we have ours lapping at the bottom side of the valve face. So at this point, to make sure that I do a good job, I think I'm going to head down to my local automotive shop. It's right down the road. I'm going to get them to grind a new 45-degree face on these valves here, and then I can go ahead and lap them in, and I shouldn't have any issues. And my customer said he's not in a rush for this. I have to order a cylinder head gasket anyways because I used up the last of my HMSK80 cylinder head gaskets. So because I have to order them, you know, my customer's not going to get this back till next week. We're going to go ahead and do that. And I also got the valves back from the machine shop. They went ahead and cut a nice clean 45-degree face onto these valves, both the intake and the exhaust. So because they're removing material on the valve face, the valves are going to sit farther down in the seat. So I'm going to put the valve back in, and then I'm going to be checking the lash with the flywheel still in the position so that the piston is at top dead center where the tappets are as far down as possible. Now, it might be a little bit of a tighter tolerance in between the tappet and the valve stem, so I may just have to touch up the valve stem tips with a file just to clean it up. My main goal here is because I knew that the intake was, I believe, at 12, and the exhaust valve was around 10, I think. So I'm hoping that it tightens up the intake side a little bit. That's one of the main reasons why I got that valve face cut, just so I had a nice clean starting point. So what I'm going to do now is start putting everything back together, and then I'll go ahead and check the tolerances, and then I'll lap the valves in. And then I have a 10 thou feeler gauge here, and then we're just going to go in between the exhaust side, and I can see that things are tightening up there. So we have less than 10 over here, and then we have about 10 here. Now, like I was saying, the exhaust valve is always going to heat up and expand. So if you had 10 thousandths of an inch over here, once this engine starts running, that tolerance is going to tighten up to about 8 thousandths of an inch. Normally they tighten up by about 2 thousandths of an inch, which is why a lot of times you're going to see manufacturers in the manual specifying to run the valve lash, as they say, bigger on the exhaust side, because there is going to be that expansion. So you would see something like 6 and 8 or 8 and 10 or 10 and 12 thou. And basically that 0.02 of an inch extra valve clearance will tighten up once the valve heats up and expands. Now, before I go ahead and remove that valve, I just want to show you that you want to have some idea about how much you want to file off. So what we have here, sorry for the focus, but this is a 0.04 of an inch feeler gauge, and I'm going to put this onto the intake side, and you guys can see, might be hard to see, but the 4 thou goes in. So the 6 thou isn't fitting, the 4 thou goes in, which means that we're either at 0.04 of an inch or 0.05 of an inch, and I'm trying to get to 8. So you guys have to understand that, this is very, very small amounts of material that we're going to be filing off of the valve stem tip on the intake side there, which is, again, why you don't really want to just take this thing to a bench grinder and, slam the valve stem into the stone that's grinding there, because we're only trying to remove about 2 or 0.03 of an inch here. So once again, just removing the slightest amount of material from the tip of that valve stem there. I'm going to go ahead and put it back in, and then we'll go ahead and check the tolerance. So here's the 8 thou. And it may be a tedious process, but we can get it in there. Check that out. So now the 8 thou is fitting. The 10 thou is really tight. So that's probably like 9 thou. And again, guys, I just wanted to stress, when you're going with thousandths of an inch, you got to be careful you don't remove too much. So I'm just using a file here and going nice and easy. So now I am ready to remove both of my valves again, and then what I'm going to do is just lap them in, and then those fresh cut faces on those valves will be lapped into the seats, and these valves should both seal up nice and tight. And just to kind of show you guys, sometimes I like to lift it up, get that lock compound in there, and then I'll go ahead and pull it out and check it. And then, like I said, just make sure that you wipe down the seat and the valve thoroughly. You could even go ahead and use a little bit of brake cleaner, blast away any valve lap compound there, because if you leave some of that compound in there, as your valve is moving up and down, it spins and rotates a little bit on lift, and it'll actually keep lapping itself in, and it'll destroy the condition of your seat and your nice clean valve face that you probably just got ground. So again, do it right, keep everything nice and clean. And then just to show you the intake side, like I said, it's not lapping on the very bottom edge now. We're a little bit higher to the center point, which is where you want to be. So the intake valve has been lapped up. So I'm going to go ahead and just spray this down, clean it all up. And then I just wanted to show you guys, I have the 10 thou feeler gauge here. So both valves have been lapped, and we are getting to the point where the 10 thou feels snug and the 10 feels snug on the intake side. So like I said, with that exhaust valve heating up a bit, we probably have this 10 and 10, so that'll be 8. Shouldn't have any issues. That's a tolerance that's well within the spec of 8 to 12. So, like I said, set them around 10 and you shouldn't have any issues. Okay, so cylinder head is all cleaned up, not a perfect job, but did the best I could to remove the carbon. Some of the stuff is just too cooked on for me to get off, so went ahead and cleaned up this surface as well. So at this point, I'm going to go ahead and put the head gasket on, get the cylinder head bolts snugged up, and then I'll bring you back for the torque sequence for those bolts. Okay, so the cylinder head's back on, and I'm just going to put an infographic up on screen so you guys can see the torque sequence. And I've rotated the infographic to line up to the position of the cylinder head here. So basically, I'm going to be torquing the bolts down as they're numbered there. And you want to torque these bolts in 50 inch-pound increments. And then you're going to be torquing this from anywhere to 160 to 210 inch-pounds. Tecumseh kind of has these wild specs that can change from the beginning or the end of the manual. So as a rule of thumb, normally I torque these cylinder heads on these HMSK engines down to 200 inch-pounds, and I do it in the sequence, and I always go 50 inch-pound sequences. So 100, then 150, and then 200. Okay, so fast forwarding here a little bit, I was able to pressurize the cylinder with my cylinder leak down tester, and no air was coming out of the exhaust port. However, now that the exhaust side has been sealed up, I noticed that there was a little bit of air leaking out of the intake side. So at this point, I'm trying to seal that up. We have to remember that I did get my valve on the intake side cut as well to a new 45-degree face, and then I went ahead and lapped that valve in, and it looks like it lapped in perfectly. However, we're still getting a little bit of leakage. So at this point, I just wanted to take a moment to show you a little trick that you can do using a little bit of 320 grit sandpaper. So in front of me, I have some automotive sandpaper, and it's important to use automotive sandpaper because it's made for metal, so you don't want to be using a woodworking sandpaper. But basically what you do is go ahead and take a little square rectangle and fold it, and then go ahead and cut the corner on a diagonal like that, and it will give you a little diamond or a little square in the center. Now what you're going to do, and you're going to kind of see here that I've already gone ahead and cleaned up the seat. What you're going to do is lay this down, and then you're going to put your valve through that hole there and slide it into the valve guide. And with the sandpaper side down, you are basically going to take both hands, put a couple fingers under there, and put a thumb on the valve. And then what you're going to do is push down with your thumb and rotate, and you're going to be able to clean up the seat. So if you'll remember at the beginning of this, the exhaust valve looked like it had already been cut by someone who worked on this previously. However, the intake side looked pretty much untouched. So I was able to go ahead and lap that valve in, and it sealed up perfectly with that new 45-degree face. But again, this side may need a little bit more work. And if this trick here doesn't work, then I could either go ahead and check the valve to make sure that it's true, which is going to be making sure that the valve stem is perfectly straight, because even if the valve is out by 1 or 2 thou, you could end up getting a high spot on one side of your valve seat, and then that would allow air to travel through. So that would be the reason for the leak. But at this point, I'm just going to go ahead and try to clean up that seat a little bit and then test it again. Now, I showed you what the valve seat looks like after it's been lapped in. It's going to be that darker gray. So once you go ahead and use your sandpaper, you're going to get a nice reflective clean surface. So that has cleaned up the valve seat nice. And then what you can do at that point is go ahead and put your valve back in, lap it in again, and then just see if you've solved the leak. So I'm going to go ahead and do that now, and then I'll bring you guys back. Okay, so a little update here. The intake valve is not sealing up. It's not leaking as much as the exhaust valve was leaking originally, but the intake side is leaking a little bit, which could cause like a backfire through the carburetor, which is not good. So obviously I want to get this sealed up. Now, what I'm going to do here is check the valve to make sure that it's true. Normally you would want to use what is known as V-blocks and set them up on the actual valve stem. I don't have any of them, so I'm just going to use my drill here. The valve has been set in place, and I'm just going to spin the drill, and you're going to try to see that wobble there. So it's quite clear that the intake valve here is slightly out of spec, 1 or 2 thou of a bend, and that will cause, like I said, that little high and low spot on the valve face, and then you won't get a nice seal. Now, like I said, I had sent these valves out to get machined, and they did say that both valves looked pretty good and that they should have no issues. So unfortunately, I'm not going to be using this valve, but I did find a replacement valve that I can use. So I have in front of me here an intake valve out of an HMSK80 Tecumseh engine, and this valve will replace that one right there. So this valve, it does not have a new 45 face cut onto it. However, they said that it came out of a running engine that they ended up scrapping due to other reasons. So this valve should work perfectly. Okay, so I went ahead and cleaned up the used replacement intake valve on my wire wheel, and I just put it in the drill here to show you guys that when I go ahead and spin this one spins perfectly straight. So, this happens to these valves even on the intake side, that, these valves here may not see as much heat as the exhaust side, but over time, these valves do heat up, and a little bend, anywhere on this valve stem will end up being greater the longer the valve stem is. So if you get a little bend down here, obviously it's going to be out more up here. So, it ended up costing me, I believe, $15 for this valve. Not that big of a deal. And the reason I didn't check the old intake valve to see if it was straight was simply because I didn't think that there was an intake valve leak. You have to remember that I didn't realize the intake valve side was leaking because we had such a large leak on the exhaust side. And then, like I said, once I sealed up the exhaust side, then I noticed a little bit of air coming out of the intake side, and hopefully this takes care of that. Now, before I go ahead and lap this new valve in, I have to check the lash, because we have to remember that this valve came off of a different engine, so the length of the valve may be a little bit too long, and I may have to file it down a bit. So I'm going to go ahead and reinstall everything here, check the lash, and then if I need to file the valve stem tip, then I can go ahead and do that. So with the intake valve spring reinstalled there, I went ahead and checked it, and it might be very difficult to see, but this is the 6,000th feeler gauge here, and we can see that that is going in. And if I flip over to the 7th thou, you guys can see that one a little more clearly. I'll try to get this one to fit in, and that one does not want to fit in. So the intake valve is currently at 6/1000ths of an inch. Now I may go ahead and file that ever so slightly just to get it to around 8, because again, you know, the exhaust side was set to 10, and then once that heats up, that should be around 8 thou. So I'm just going to try and keep them around the same. So I'm just going to remove the valve and take 2/1000ths of an inch off of the valve stem tip and try to get that to 8/1000ths of an inch. So again, I don't have any expensive machining equipment. I simply just use a file on my workbench here, and I was able to take off the slightest amount of material. Again, we're working in thousandths of an inch here, guys, so it's very small amounts of material. You're not trying to grind that edge down too much. Okay, so I took the intake valve out a total of 2 times to file it, because again, you know, very small amounts that we're filing. Here's the 8 thou, here's the 9 thou. So I just want to show you guys, if we come down here with the 8 thou, try to get a nice shot. The 8 thou goes in, right? And the 9 thou, try to get a nice shot there, does not want to go in. So the intake valve is now set to 8/1000ths of an inch, which is perfect. So at this point, go ahead, put my lapping material on, and then lap the valve in. I'll show you guys a quick shot of that, and then we'll go ahead and finally get this thing reassembled so I can pressure test it again. Fingers crossed that the intake side now seals up. And then once again, we'll go ahead and lap this new valve in. I occasionally like to lift it up and rotate it to get that grit mixed in there properly. And, you know, valve work really isn't hard work, but you want to make sure that you do a proper job. And now that I'm happy with how the intake side looks, I've gone ahead and used a little bit of 3-in-1 oil here, and I'm just lubricating the valves so that on the first startup, you know, you can see how easily that dropped in there, nice and lubricated, so nothing's going to be burning up. It might smoke a little bit, but you know, a little bit of lube is better than none. All right, so I've gone ahead and pressure tested it. My compressor has 50 psi being put into the cylinder, and the cylinder is currently holding at around 45 psi, which means that 5 psi at 50 is going to be a 10% loss, which is okay. So that means that everything is sealed up properly. The only place that air is leaking is out of the breather port here and out of the dipstick here. And there is no more air leaking from the intake port or the exhaust. So that's a job well done. It gets very difficult to hold the flywheel because you have to remember that we're up on top dead center of the compression stroke, and then I rotate the flywheel clockwise so that the piston travels down just a little bit on the power stroke. So what's going to happen is as soon as you pressurize that cylinder, all of that pressure pushes down on the piston and it wants to rotate the flywheel. That's why you hold the flywheel, pressurize it. But to make things a little easier, normally I pressurize up to 50 psi. So at 50 psi with a 5 psi loss, that's 10%, which is in our acceptable range. So at this point, I'm going to put this thing back together, take it outside and fire it up, and I'll bring you back for a clip of that. All right, so everything has been reassembled on this snowblower here. I'm going to prime it and see if it fires up with the choke off. So that's it, guys. The John Deere TRS26 with the Tecumseh HMSK80 valve job is complete. This snowblower runs and functions again, and all we had to do was seal up those valves. Well, that's going to wrap up today's video. Like I said, a full in-depth valve job on that John Deere TRS26 snowblower with the Tecumseh HMSK80 engine. It was unfortunate that we did run into some complications at the end there with the original intake valve not sealing up, but once I got that used replacement valve, put it in, lapped it in, and we were able to get everything sealed up. And as you guys saw at the end there, the engine runs perfectly. But with that being said, if you guys enjoyed the video, think about leaving me a thumbs up. You know, it really helps me out. You can click here to subscribe and click over here to watch one of my previous videos. I upload every single week, so be sure to stop on by next week. Check channel out for new content. And as always, guys, thanks for watching.